Okay, so there's some other optimization type problems, and usually they have a little extra bit at the beginning that can be a little bit trickier. So I've written some stuff in red here that's the standard format that these optimization problems take. So usually there are two variables involved. Like in this case here, you can see that there's x and there's y. You may have to introduce one yourself if they haven't told you it. And usually these are probably going to be lengths. There are expressions for two different physical quantities. So one is a constraint. For example, the surface area of something may be fixed as 20 centimeters squared. And then there's another expression for some kind of physical quantity, which is the thing that we want to either maximize or minimize. So maybe the fixed one is that the surface area is 20 centimeters cubed, and it may be that we want to maximize the volume of a box or a container. What we do is we use the constraint to eliminate one of the variables in the second equation so that it is just then in terms of one variable. And then we can differentiate that to find the turning point, etc., etc. So when you look at this question here, you'll notice that y is involved as one of the lengths of this cuboid, but then when they're talking about the volume of it, y isn't involved anymore. And that's because one of the variables, the y variable, has been eliminated. So let's just read this question to get a bit more of a sense of what's going on here, and then we'll see how these bullet points that we've got come out in practice. So it says figure 4 shows a solid brick in the shape of a cuboid measuring 2x by x by y, and the total surface area of the brick is 600 centimeters cubed. And we're going to try and show that the volume of the brick is given by this. Well, there's no point in just going in and saying straight away, oh, well, the volume is actually these three things multiplied. So the volume is just going to be 2x squared y, because we don't know what y is. So we'll come back to that in just a second. I'm going to start off by using this fact, which is the constraint that the surface area of the brick is 600 centimeters squared. That is fixed, and we can't change that. So let's actually work out what the surface area of the brick is. The surface area is going to be, well, you've got two of these ones. So that's going to be 2 times 2x squared. You've then got two of these ones, which is going to be 2 lots of xy. And then you've got two of these ones, which is 2 lots of 2xy. So in total, we have 4x squared plus 2xy plus 4xy, which is 4x squared plus 6xy. And they've told us the surface area is 600. So I'm just going to write down now that the surface area, 600, is equal to 4x squared plus 6xy. Looks like everything could be simplified here a bit. So I'm going to just do some division, and I'm going to say that we get 300 equals 2x squared plus 3xy. Now you'll notice here, for the thing we're aiming for, there is no y. So what we're going to do is we will make y the subject in this expression that we've got here. We're going to make y the subject and then find the volume. Okay, might be a good idea now to say what the volume is. We know the volume is just those three things multiplied, so that's 2x times by x times by y. So we're going to make y the subject in this one over here, and then we're going to substitute it into the volume. So let's just quickly do another bit here. The other one is the thing we wish to maximize or minimize, is going to be this formula. Let's make y the subject then. So that's going to be 300 minus 2x squared divided by 3x is equal to y. Now that I've got that, I can substitute it into the volume, which is 2x squared multiplied by y, which is 300 minus 2x squared divided by 3x. So let's just expand all of this. I'm going to then get 600x squared minus 4x to the power of 4 divided by 3x. Now, instead of doing the whole thing divided by 3x, you know that you can just do this one divided by 3x and this one divided by 3x. So when we simplify this, the 600 divided by 3 is 200, and the x squared divided by x is x. And then here we've got the x to the power of 4 divided by x, which is x cubed, and we've got the 4 over 3. I'm just going to check how they've got it, and they've got it written like this. This is the thing they wanted us to come up with at this point here. So just going back to what the question said, we've actually done this bit. We have eliminated one of the variables, and then we have now created a formula that is just in terms of one variable. We're now going to do the last bit, and we're going to use differentiation to find the turning point, because that's what happens in part B and part C. So it says, given that x can vary, use calculus to find the maximum value of the volume, giving your answer to the nearest centimetre cubed. Then we want to justify that the value of v you have found is a maximum. So let's just quickly think about what our strategy is going to be here. We're going to find out what dv by dx is. Then we're going to make dv by dx equal to 0. That will tell us what x is equal to, but they want us to find out what the volume is equal to. The second part, we're going to use the second derivative, and we want it to be a maximum, which means that it is going to be less than 0. So let's have a go. I'm going to add in a blank page here because I know we're going to take a bit of time for this. So we've got v is 200x minus 4x cubed over 3. I like writing it like 4 over 3x cubed. So dv by dx is going to be 200 minus 4 over 3 times 3 is 4, and I'm going to reduce that power by 1. I'm now going to say that dv by dx is equal to 0. In other words, 200 minus 4x squared is equal to 0. So 200 is equal to 4x squared. Dividing both sides by 4, I get that 50 is equal to x squared. And so x is equal to the square root of 50. But that's not what it wanted. They want us to find out the maximum value of v. And we've done a couple of these bits. We found dv by dx, we made it equal to 0, we found out what x is. We now need to find out what v is equal to. So let's go back. We're going to use our formula that's at the top. So v is equal to 200 multiplied by root 50 minus 4 over 3 times root 50 all cubed. So I'm going to go to my calculator. I'm going to put in root 50 as my answer. I'm going to do 200 of the answer minus 4 thirds multiplied by my answer. Whoops, not squared, but cubed. And so the maximum value of the volume is 943 centimeters cubed, and that is to 3 significant figures. I don't think they asked for what they wanted it to. They did. They asked for it to the nearest centimeter cubed, so it's 943 centimeters cubed. That's to the nearest centimeter cubed. All we need to do now is justify that this is a maximum. So we said that the strategy for that is to do the second derivative. So the first derivative, dv by dx, is 200 minus 4x squared. So when I differentiate this again, I'm going to get d2v dx squared. The 200 is going to go, so you're just going to get minus 8x. And clearly, when x is equal to root 50, we get that the second derivative is equal to minus 8 root 50, which is clearly less than 0. Hence, this is a maximum volume. Something I just want to point out here is I've marked hundreds of students doing these questions. Usually what people do is they forget to do this last bit of actually finding out what the volume is equal to. They've done all of this hard work here. They find out the value of x and they forget that it actually wants you to find out the volume. So use that formula that it's given you. Okay, I'm going to do one more and then you're going to have a go at one. So you can see how they're often to do with shapes in these questions. Figure 3 shows a flower bed. Its shape is a quarter of a circle of radius x with 2 equal rectangles attached to it along its radii. Each rectangle has length equal to x meters and width equal to y meters, given that the area of the flower bed is 4 meters squared. So this is the constraint that we've got here. And then we're going to try and find out what the perimeter of it is later on. And that's going to be the thing that's the bit we're going to be differentiating. So they've kind of structured this question here. They've actually asked you to find out what y is equal to in the first part. So let's figure out what the area is. Well, the area is 3 different shapes. We've got 2 of them which are identical, which are xy. So there's going to be 2xy. And then we've got this quarter circle that we've got here. And the radius of that circle is x. So it's going to be a quarter times by pi x squared. And they've said that the area is 4. So I'm going to replace a with 4. And I'm going to get 2xy plus a quarter pi x squared. So let's do some rearranging because I want to find out what y is equal to, as you can see here. So it's going to be 4 minus a quarter pi x squared, all divided by 2x is equal to y. So it's nearly the same as this, but things look a bit different. There's no fraction here. This is a 16 and not a 4, and this is an 8x and not a 2x. So you can just use your knowledge of fractions. You can multiply everything on the top by 4, and as long as you do the same to the bottom, it's going to stay completely the same. So y is going to be equal to 16 minus pi x squared over 8x, just as they wanted you to do for that bit. Now it says, hence, show that the perimeter of the flower bed is given by this equation. So we're now going to, for part B of the question, we're going to come up with an expression for what the perimeter is. Well, let's ignore the fact that we know what y is. Let's just do everything in terms of x and y. So it looks like we've got an x and an x, so that's 2x, and then 1, 2, 3, 4 y's. So let's write that down. So we've got 2 x's and 4 y's. And then we've also got this kind of curved section over here. And this curved section is going to be a quarter of the circumference of the circle. So the circumference of the circle is 2 pi r. So we're going to do 2 pi x. And we're going to multiply that by a quarter because it's just a quarter of that 2 pi r that we've got there. So let's keep working on this. We know what y is equal to, so I'm going to sub that in as well. So p is equal to 2x plus 4 multiplied by 16 minus pi x squared over 8x plus 2 times a quarter is a half, so it's plus a half pi x. Now we're just going to keep working on this expression until it looks like the bit that I've got in yellow. So I'm going to do some cancelling. I can divide the top by 4 and the bottom by 4 so that I get to this expression here. So I have 2x plus 16 minus pi x squared over 2x plus a half pi x. I'm going to split that second fraction into 2 pieces. So I have 16 over 2x minus pi x squared over 2x plus a half pi x. I'm going to simplify some of these terms. 16 divided by 2x. Keep the x on the bottom. It's not going to change. Not going to suddenly magically move to the top, but 16 divided by 2 is 8. And then for this bit, I can divide the x's. So x squared divided by x is just x. And I have pi over 2, which is the same as a half pi. So this is a half pi x plus a half pi x. And hopefully you'll notice that these two here are going to cancel, so that the perimeter is just equal to 2x plus 8 over x, which is what they've got here. Do you notice how I didn't really spend a lot of time even reading what this was? Because if you sometimes get too fixated on what you're aiming for, you can get you can lose track of what you're trying to do. You should just try and do what you're doing, and then just say, am I getting close? Oh, good, the pi bit's cancelled. That's a good thing. So we're now going to try and use calculus to find the minimum value of p. Even if you couldn't do part A and B, you could do part C, and you could do part D. So don't throw away the whole question just because you get stuck on one bit. Make sure you can try some of the other bits too. So we're going to find the minimum value of p by using calculus. That means I'm going to differentiate it. I'm going to do dp by dx. It's just going to go to 2. Well, maybe I'll quickly rewrite this. So I have plus 8x to the minus 1. So the 2x is going to become a 2. That minus 1 power is going to make it become minus 8. And then it's going to become minus 2 like this. So add in an extra page. I want dp by dx to be equal to 0. So this means that 2 minus 8 over x squared is equal to 0. 2 equals 8 over x squared. 2x squared equals 8. Dividing by 2 and you get 4. And so x is equal to 2. Obviously x could be equal to minus 2, but in the context of this question, it doesn't make sense for x to be a negative length. So we're just going to keep x as that positive value. So we want to find the minimum value of p. We actually now need to find out what p is equal to. So when x is equal to 2, p is equal to 2 times 2, that's 2x, plus 8 divided by x, plus 8 divided by 2. Make sure that you're subbing it into this one and not into the gradient function. We're trying to find out the perimeter, not dp by dx. So the perimeter is going to be 4 plus 4, which is equal to 8. And I'm just going to check the units of this question. It's all in meters. So the perimeter is 8 meters. Last thing it wants us to do is to find the width of each rectangle when the perimeter is a minimum. Give your answer to the nearest centimeter. So the width of it, well, let's see what it's talking about, because I don't know which letter that is, the width. It says that it has a length is equal to x and a width equal to y. So all we need to do is we need to use this bit that we came up with before and find out what y is equal to, and just substitute in that value of x. So for part D of the question, we're going to say when x equals 2, we want to find out what y is equal to. So the formula for y is 16 minus pi x squared over 8x, which would be equal to 16 minus 4 pi, because 2 squared is 4, divided by 8 times 2, which is 16. So does it want it as an exact form? Give your answer to the nearest centimeter. So I can actually just type this into my calculator straight away. So I'm going to do 16 minus 4 pi, and I'm going to divide that by 16. So this is 0.2146 meters, 0.2146 meters. Remember, it wants that 0.2, I can't even remember what I've said, 2146 meters. Just check what the question says though. It wants it to the nearest centimeter. So I'm going to multiply that by 100. So that's 21.46 centimeters, which is 21 centimeters to the nearest centimeter. Okay, so I'm going to give you this one to have a go at. Pause the video here and have a go. I'm going to do this one now, and then you can try exercise 12K, and that is us finished before I then go and do some exam questions. Okay, so this time we've got a manufacturer produces pain-relieving tablets. Each tablet is in the shape of a solid circular cylinder with base radius x and height h as shown in figure 3, and they're all in terms of millimeters, which is worth noting. Given that the volume of each tablet has to be 60 millimeters cubed, so the volume is the thing that is fixed here, we're going to try and find out what h is in terms of x, and then we're going to do something with the surface area afterwards. So let's start off by thinking about what the volume is. Now we know the formula for the volume is the area of the cross section, which is pi x squared, multiplied by the length, which is pi x squared h. And they've told us that the volume here is 60. So this is for part A. I always like doing this next to the diagram so I can see it. So 60 equals pi x squared h, and we want h in terms of x, we want h equals. So h equals 60 divided by pi x squared. Next thing it wants us to do is to show that the surface area is given by this. So let's find out what the surface area is with h, and then we'll do the substitution. So let's see if I'll draw the diagram to see if I can make this a little bit easier rather than going back and forth. So it's x here and it's h. Well, first of all, the top and bottom is going to be two lots of, I think they just called it A, I won't call it SA. Two lots of pi x squared. That's the two circles that we've got there. So I'll put 2 pi x squared. That's the two circles. Now the next part is like a rectangle. If you imagine cutting it, it would end up being a long rectangle, and this distance along the outside is going to be the circumference, and the height of it is h. So it's going to be the circumference, which is 2 pi r, or 2 pi x, multiplied by the height. So all we need to do now is substitute in the thing that we found out in part 1, which is that h is equal to 60 over pi x squared. So the area is equal to 2 pi x squared plus 2 pi x multiplied by 60 over pi x squared. There's some things that cancel here. A pi in the top, pi in the bottom, the x in the numerator with the squared in the denominator that we've got there. And I'm just going to simplify so that we have 2 pi x squared plus 2 times 60 is 120, and it's over x, which is just like we've got here. Now imagine that you got stuck and you couldn't do A and B. You can still do C, D, and E. It now says that the manufacturer needs to minimize the surface area of the tablet. I don't know why they need to minimize it. It might be something to do with the way that it enters the bloodstream, who knows. So we're going to use calculus to find the value of x, for which a is a minimum. Then we're going to find the minimum value of a, and then we're going to show that it is a minimum. So there's some steps for this whole question. We're first of all going to differentiate it to find out what dA dx is. Then we're going to make dA dx equal to 0, and then we're going to find out what x is. That's for part C. Then we're going to find out what a is for part D. And then to show that it's a minimum, we're going to differentiate it again, and we want it to be greater than 0. So that was part A. This is part B here, and now we're going to do part C. So I'll start off by differentiating it. So dA by dx is going to be 4 pi x. Remember this thing that I've written here, this is 120 x to the minus 1. So when I differentiate it, I get minus 120 x to the minus 2. And I'm just going to solve this equation. Okay, so I want it to be equal to 0. So that means that 4 pi x, I'm going to skip a bit here, is equal to 120 over x squared. I'm going to multiply up by the x squared so that I get x cubed, and I'm going to divide by 4 pi here. So x is going to be the cube root of 120 divided by 4 pi, and I'm going to do the cube root of that answer. So x is 2.12 not centimeters, millimeters, and that is to 2 decimal places. But I'm going to keep this stored in my calculator here because I think I'm going to need it for the next part of the question. Part D says calculate the minimum value of a, giving your answer to the nearest integer. So a is equal to 2 pi x squared plus 120 over x. I'm not even going to write it out, I'm literally just going to type it straight into my calculator. So just to make sure I've got that stored as my answer, it's going to be 2 pi answer squared plus 120 divided by the answer. You can see how I'm just copying out the formula for the area here and just replacing x with the answer. And we get 84.84, but it wanted it to the nearest integer, so it is 85 millimeters, and because it's area, it's squared, and this is to the nearest integer. Part E of the question, we want to show it's a minimum, so we're going to differentiate it and show that it is greater than 0. So the dA dx, I'm just writing it out again so I've got it right in front of me, is this. So the second derivative is going to be 4 pi, because remember pi is just a number, plus 240 x to the minus 3. And so clearly this is going to be greater than 0 when x is equal to 2.12. If you want to, you can substitute 2.12 in. I'll show you what happens when you sub it in. So you would have 4 pi plus 240 times by 2.12 to the power of minus 3, and you get a positive value, you get 37.7. So why don't we just do that? Second derivative is 37.7, which is greater than 0, hence this is a minimum. Did it want for A? This is a minimum value for A. Okay, so that's all of differentiation. I hope that question went well for you. I'm just going to do a few more videos now on some exam questions on this topic.